Hello everyone, my name is Rajesh Sharma. Today I am here to show you my Anthem project in AI at scale. So here we have created a end-to-end MLOps pipeline where we classify this Titanic dataset where we predict survival rate or on the basis of features like age or gender, those features. Let me show you the dataset itself. So these are the features. So first we created some classifiers, and let us check on ML flow UI how they are working. Let me create terminal in this folder only, ML flow.ui. So we can copy paste this one in our browser. So this is running. Let me do it. So these are the classifiers we have I have trained with a different type with different hyperparameters. Mm, Three classifier I have tried: gradient boosting, random forest, and logistic regression. Let's uh, let's check it. Let me start new terminal where we we are updating our code if there is an update. I have created one. I have created one file where I have put all the commands. So first we need to activate the environment. Now environment is activated. We need to run dvc repo to update if there is any update. Let's see if anything is happening here. So as I run that dvc repo that used to update our model if there is changing in if there is some change in training or training.py or in training data itself. So model are showing here that logistic regression, random forest, and gradient boosting. Gradient boosting also training. Shows training is finished. Let me check. Yeah, all three classifiers are trained. So you can check this model is best. So this is registered to in our in our model.py. So this is the latest version. Actually all these versions are same, but this one is I had created as a production one. I'm getting best accuracy in this, and I am thinking this is the same model, we can stage it also as production, as I haven't changed any code. Okay, let's compare the model first. You can see there is gradient boosting is comparatively good in all metrics. In model we can stage the models. Currently version 7 is as a production, so version 9 we can stage as a production. So version 9 is now in production, which is latest one also. So now we have to do it. Let me check. Yeah, now we have to execute this UI interface. I have created app.py. Let me show you also. So this is app.py. Currently I am doing it internally, not in Docker. So I have to change this to and comment out this. So currently we are running on this internally on my machine. So, and if we are using Docker, we have to change the path like this. Inside a Docker we are creating the port. Okay, save. And if we run that here, our app is running, where this is a user interface where we can put all the details like features, and we can know the passenger will be survive or not. We can change any things like siblings and parents to 1, and I can change age to 48 40. And let's check, this is passenger is survived. If I changing something else, let's check. Now the result is changing. So this is the UI. I use that in Python only. I created with that stream it. Let me show you. Streamlit framework I have used here. So we can see the AUC score, accuracy, FN score also there. The version 9 is also showing here, which is on production, and this is our best model. Let me show you how drift defect mechanism is happening. So this is my drift detect drift file. This used to check like if there is a difference between training data, if new data is added. So, and for a certain threshold limit it is not giving any alert, and after a particular threshold the data is changed a lot more, then it will giving some alerts. And we are using this divergence JSON 7 here. And uh, this is automated file, this sh file. So here what it is actually is doing, it is initiating or triggering that detect.drift file, and checking this we need to update our model or not. And if it is like our detect.drift_by is saying that there is significant amount of change in training data, then it itself create a change. Let me show you how. Before that, I wanted to that I have some new data.csv. This is some custom data I have added manually, and let me add this data to our existing data. If I executed this file, sh file, it added that data, this train data to new data automatically, and and check this detect drift file. Accordingly, it acts. Okay, let me show you. This only we need to check. I need to create new environment, new terminal, I think. So it basically saying that there is a significant data drifted, so which is above the threshold limit, so we have to train our model again with new data. That's what it is doing. So we are again training our model, and let me check. I think here also, right, so here training happening again, this logistic regression, which logistic regression is training right now on new data. Now random forest is training. So we are doing all the process again for new data, and it is checking that if we need to change our model or not. This is automatic process. Now our gradient boosting is training. Yeah, I think it is trained, and at the end it is also saying that a new model is not better than the current production model, so we will kept it. Although the data is changes, but we need not to shift to any other model. So this is the automatic defect or detector, you can say that, drift detector, sorry. So let me show you again. So where are we? So with Docker, actually this is complete pipeline. I have deployed all the pipeline in Docker itself. Let me start Docker, and I already activated environment. I have created my image also in Docker file, so we need not to do that here, but we need to change the path in app.ui. I will do that, and after that we need to run this first. first I need to close this existing one. Before that I have to change that app.py. Now in terminal I have to start my Docker. Sorry. I pasted wrong. So here this Docker, so our app is running here. This time we are doing in Docker. Let's do survive. Yeah, if I changing to some one, now it's just, yeah, so it is working fine. This time we have done this in Docker. So that's it from my side. Thank you.